So, continuation of 8.5, we're in B as in Bravo, and I'm on page 693, and I'm ready to start applications of logarithms. Applications is just a real nice way of saying story problems. So we're just going to start in example 6. Now, when you're doing these story problems, they will always give you the formula. So that's very helpful as we're doing these. So the formula they give us in C is m equals log of t. Now again, this is an assumed 10 down here. All right, so it gives us an example 6, the San Francisco earthquake, and it's said to have measured 8.3 on the Richter scale. Now, if you look just a little bit above under applications of logarithms, it will tell you what m and t represent. So m, let me get my pen here. M represents the magnitude of the earthquake. Now in Alaska, when we get earthquakes, it's a 5.2. It was enough to jiggle a little bit, but not too terrible. But if it was an 8.4, it's going to be knocking buildings down. So we kind of have an idea of the Richter scale and magnitude. As far as living in Alaska, T is going to be representative of the shock wave, how much bigger than it is than the smallest shock wave that the Richter scale can measure. So I'm just going to put shock there. All right, so those are the two variables that we have. So in 1906, we've got this earthquake that measured 8.3 on the Richter scale. The San Fernando earthquake of 1971 measured 6.6 on the Richter scale. Find T for each earthquake. All right, so we're going to look at them one at a time. So m equals log of t. Well, the magnitude of the first earthquake in San Francisco, it says, was 8.3. So instead of an m, I'm going to put an 8.3. That equals log of t. All right, so I know I'm going to use the anti-logarithm because the number is on the other side of the equal sign. And that's a key piece to know whether or not you're going to use an anti-logarithm or a logarithm. Anti-logarithm always has the number on the other side of the equal sign from the log. So that will help me there. So all I have to do for this one is I know that 10, which is my number there, of 8.3 is going to give me T, my shock wave. So all I'm going to have to do is take my calculator, do my 10 to the x power, and I'm going to put the 8.3 in there for my x, and that's going to give me my T, which you should get 2 times 10 to the 8th power, or 2 with 8 zeros after it. So that ends up being, what was that? Nope, that's 9 zeros, sorry. Anyway, 8 zeros after it. All right, so the next one, it said, same thing, nothing has changed at all. The only thing that has changed is the city where the earthquake took place and the magnitude of the earthquake, and in this case, it's 6.6. So 10 to the 6.6 equals what? And in this case, it'll be 3.98 times 10 to the 6th. And that's the shock wave. So, like I said, if the number they give you is all by itself on the other side of the equal sign from the log, you'll be using your anti-log key, which is 10 to the x. If the number is given here with the log, you'll just hit the log key. All right, so next thing we're going to go into where logarithms are used extensively is in chemistry, and specifically what is called pH. Now, I do not promise that I know a lot about pH. I'm not a chemist, but I do know how to use logarithms in chemistry. So here's the formula. So it's kind of a weird looking formula. Okay, that's a really lame parenthesis. Sorry about that. or bracket. All right, so what this is, pH, it goes from 0 to 14, and that determines how acidic something is. So, milk has a certain amount of acid in it. Vinegar has even more. Battery acid has tons. And then you've got other things like ammonia, lye, seawater, baking soda. And if you look in the middle of page 695, it tells you kind of some ideas of what we've got as far as that 0 to 14. So neutral is right in the middle at 7. But as you go higher and higher in a number, it's called an increasing alkaline. So both of them, as you get into the extremes, can burn you or hurt you. It's just a different way. So, for instance, baking soda would be in the 8 range, above 7. And things like apple juice would be in the acid range. Tomato juice would be down in the acid part. In fact, all the way down at the very bottom with a 1 pH, you've got battery acid. You know what that can do to you. So anyway, that's the scale that we're looking at. You don't have to understand it all. Just know that it is a scale, just like a thermometer takes a temperature. This takes a reading of how acidy or how alkaline a substance is. So it's between 0 and 14. So again, we're going to use the calculator, and we're going to use this formula then to solve some of these problems. So example 7 says normal rainwater has a pH of 5.6. So little p, big H. Okay, 5.6. What is the concentration of the hydrogen ion? That's what this is called. If you remember from high school, you might have learned your periodic table where letters represented certain materials. In this case, the H represents hydrogen. The plus sign tells me that it's an ion. So when they say the hydrogen ion, they mean this part right here. And that's pretty much all you need to know about that. So in this one, it says normal rainwater is a pH 5.6. What is the concentration of the hydrogen ion in normal rainwater? So what do they want? They want to know what this number is, given that that's 5.6. So we're going to write this as 5.6 equals negative log H positive. Now, if it makes you figure this out better, we can change that because that's kind of messy. Just change it to X if you want. That H to the positive just represents the hydrogen ion. We're just looking for this number, okay? So what we're going to do here is we are going to, first of all, get rid of this negative here. We just want to know the logarithm, not the negative logarithm. So all we have to do is change it to a positive, change that to a negative. Because what we did is we multiplied the entire thing by a negative, and so that changed it, both sides of the equal sign, to its opposite. So that changed my log. That's the first step. Change your logarithm to a positive. Change that number to its opposite, which in this case is a negative. Okay, now all you have to do is use your 10 to the x key and plug that 5.6 in, because again, it's anti-logarithm because it's all alone on the other side of the equal sign from the log. And 10 to the x with the negative 5.6, and you're going to get an answer of 2.5 times 10 to the minus 6 moles per liter. And that's, again, some chemistry phrases there that you don't really have to understand. You just have to understand how to find that problem. Okay, so let's do one very similar, but let's go kind of backwards here. All right, if I can erase, let's see, what's my eraser? There we go. Okay, we're going to use the same formula, but this time, example 8, the concentration of the hydrogen ion in a sample of acid rain known to kill fish is 3.2. Okay, so now they're telling me the hydrogen ion, and that's 3.2 times 10 to the minus 5 moles per liter. We don't need to understand any of that. We just need to know what we're substituting. So now we have pH equals negative log, put this in parentheses, 3.2 times 10 to the negative 5. Okay, so now we have to use our log key on this one. So we're going to hit our log key, log. We're going to put this number in there. Now, some of your calculators, golly, they may have all kinds of different things on here. Let me bring that other calculator up here and see what key theirs has for putting something like 3.2 times 10 to the minus 5. Let's see. All right, I don't see it. I bet it's the yellow or orange shift number behind here. That's usually where it is with the x squared, but I don't see it. Okay, so I guess you're just going to have to deal with me giving you what the key looks like. Usually what it looks like on a calculator is just a button that has the letters E, X, P in them, meaning exponent. So you push 3.2, then you push the exponent key, and you put the exponent right here, there, okay? And that would be the number that you want. So log of exponent, or I'm sorry, log of 3.2 exponent negative 5, and that should give you a negative 4.5. So that would take care of all of this to get negative 4.5. You still have this negative right here, so let's bring that down. So that gives me a positive 4.5, which means that's what my pH is. And you will always get a positive pH. If you get a negative number for this, you've got something wrong with your negatives. So that's pretty much all you're going to do as far as pHs are concerned. All right, so I am going to continue on, and this might make this video a little bit longer, but I'm going to continue on with natural logarithms, and need to leave my handy dandy calculator here. I will be using that. And in the last section, logarithms, we had a log, and when we didn't have anything there, it was an assumed 10, okay? There are other bases that are out there, and the two most important ones are log with a base 10, and we just write it as a log. And then we have another one that we're talking natural logarithms here that has a base e. Now, base e is kind of like pi. You know, pi is 3.1415, et cetera, et cetera, et cetera. E is kind of the same thing. It represents 2.8, I think it's 2.81. So I don't use it that much because I just use the E key on my calculator, but it just represents a number. Rather than writing the number, we just write E, and it all comes from percent, interest, all that kind of stuff in the banking world. We aren't going to go into where E comes from, but just look at the base E. That is a, whoops, wrong button. Base E is a natural logarithm. Log is with a base 10 is a common logarithm. And we don't write log of E. There's another way to do it that's simpler, and it's just represented by the letters ln. So ln equals or is the same as log with a base of E. So if you need to switch back and forth, you can do that. Now, example 9 gives you some truths or postulates, I guess you could say, as far as what different things are. E to the O, or to the 0 power, is 1. Any number to the 0 power is always going to be 1. E to the first power is E. Let's go to ln of E, and that equals 1. If we were to write this in log form, we could write it as log E of E equals 1. And then if we write it in exponential, E, this E, to 1 power equals what? well, anything to the first power equals itself. So that's where ln of e becomes 1. And they have a list of what they equal there. And if you look at E, F, and G, notice that E, F, and G are all equal to their exponent. And we learned that back in 8.4, I think, where we had all of those different rules. So that's what we have as far as natural logarithms. They're worked just like common logarithms with log, but now we have ln. So they want to jump into one particular section that students kind of scream about, but it is important to learn, so we're going to kind of go over it just briefly, and then we'll be done. So in the example, they give you ln of 2 equals that, ln of 3 equals 1.0986. And before I go into anything, let me go back to my calculator here. All right, so notice when we are dealing with common logs, we had a log button and a 10 to a power button. With natural logs, we have the same thing. I mean, it's done, like I said earlier, the exact same way. It's just now we're pushing this button for the natural log, and we're using this button if we're doing the anti-natural log. So the buttons are used for the same thing. It's just a different way of doing logarithms. Okay, so in this problem, they give you what the natural log of 2 is and what the natural log of 3 is. And they said, okay, that being the case, find ln of 6. Now, in your old stuff in 8.4, we learned that, well, we'll get to that in a minute. We could write ln of 6 as ln of 2 times 3, because we want them in a 2 and a 3, because we know what the log of 2, or the natural log of 2, natural log of 3 are. So we're going to break the 6 down to 2 times 3. And then if you remember right, we could write these as log of 2 plus log, or natural log of 3. Remember doing that? When they're multiplied, it's the same as add. So now all I have to do is take ln of 2 and add ln of 3. This number plus this number is going to give me my answer. So you split them up into multiplication, but you can't just do, oh, I'm going to take this and multiply it by this. That's not what we're doing here. Remember, we have to split them up. We have to expand them before we solve it. You can't multiply. So don't attempt to do that. All right, so they give you another one, ln of 5, or 0.5. Well, that is the same as the ln of 1/2. Man, my equal signs look terrible. And if you remember with 1/2, when you're dividing, that's ln of 1 minus ln of 2. And if you look back on page 695, they give you, in the middle of the page, example 9D, ln of 1 is 0. So we're doing 0 minus ln of 2, which is that right there, 0.6931. So you get negative that. All right, so another one they give you, and then we'll be done, is letter C. And they are, let me kind of draw a line here. For some reason I can't erase that. They're giving us, let's do it in black, ln of 8. Well, we have to make that into a 2 or a 3 or both. So what we're going to do is we're going to make that into ln 2 cubed, which again from 8.4, this is 3 ln of 2. Remember, you take that, move it to the front. Well, now we have our ln of 2, so 3 times our ln of 2, 0.6931. Multiply those, and you be done. Okay, so that is it for 8.5.